So now that we've talked about the elements in NHST, we want to talk about the actual steps in conducting NHST. And these 7 steps that we're about to outline are the same 7 steps you will use regardless of the analysis that we're talking about. In fact, it's going to be very important for you to have these steps somewhere written out. I do have posted on my Fire a sheet of paper that you can print off with these 7 steps delineated. But regardless of what you do, I am going to be asking you to look at these 7 steps, and we're going to walk through them each time we conduct some type of analysis. So just to have them handy, I'm hoping that these will just become second nature as we go through this course. And as you move into your dissertation, you'll probably want to pull this back out and talk about the steps and walk through the steps related to your particular analysis. So what are the 7 steps? First step, state the hypothesis. We've got to know what question we're asking, okay, before we can talk about what the answer is. And it's very important to get this right, okay? So typically when we talk about a hypothesis, we're talking about this in terms of the population. If you recall, we're interested in something globally or something from a large population, and from that population we draw a sample. It's not that we're really interested in just what's unique about this handful of people. It's really what can we say from these handful of people about the whole population from which they're drawn. So really when we're talking about our hypothesis, it's not a hypothesis simply for the sample, it's a hypothesis for the entire population. The second step that we want to look at is then examine our data, and based on our hypotheses, the question we're interested in, we want to look at the data and decide on the test we're going to use. Now by the time you get through this course, you're going to have several analyses in your toolbox that you can use depending on the data and the question being asked. And so that's sort of what we want to do with this step. Now I will tell you it is possible, and it happens on occasion, where you look at the data, have a question, and you run the wrong test. And you can run the wrong analysis on your data. And so it's very important that you understand your question, your data, and then which test is most appropriate for analyzing the question and the data that you have. Okay, so very important as we move forward. Step number 2 is critical. Actually, all of these are critical, but step number 2 is where some people can go wrong. All right, the third step is we want to choose the critical p-value. When we talk about the critical p-value, it's basically the point at which we're going to draw the line and say this is the level we're looking for. So if you go back to our example of the ACT scores, I asked you what is the probability of getting a 1.27 or higher. So if we had plotted that 1.27 on our standard normal distribution and drew the line here, okay, and so we said this was 1.27, and we were looking for those scores or higher. This would have become what we call as our critical value, our critical region. It's the region for which we are looking. Okay, this is what we are trying to figure out or ascertain. And when we calculated this 1.27, we came up with a p-value that was related to this 1.27. That would be the critical p-value for our question. Okay, now, if you'll note here on this presentation that we say this is equal to alpha. And just a little language issue here, if you will. It's a statistical notation. Alpha is typically written as the Greek letter alpha or Greek symbol alpha. And whenever you see that, you'll know that they are referencing in their analysis or in the article that you're reading this critical p-value. It's just one of those nuances in stats. Again, I told you before, knowing what's being said is half the battle. So when we talk about a critical p-value, we're also generally talking about alpha. What is the region we're looking for, or what probability of scores are we looking for? And as you notice there in the parentheses, typically in social sciences we're talking about one of 3 values. It's either 0.05, 0.01, or 0.001. Typically for us, unless otherwise stated, I guess broadly even across psychology and education, it's 0.05. That is generally the level we're looking at. On occasion, we may drop it down to 0.01. For this class, I do want you to know it's going to be 0.05 unless otherwise stated. In the absence of any specific direction on what the critical p-value is, social science research, by far and away, it's 0.05. Again, though, you will see occasions where it's 0.01. Where we tend to see the smaller level of 0.001 comes more in epidemiology and medical research, where we are trying to find fewer and fewer people, or a percentage of people. The basic reason for this is the probability of getting that score just randomly is smaller and smaller. And so you think about it in terms of medications that we take and different things. We really want to be sure, or more sure, that this isn't some just random error. It's not likely to happen just randomly. So we make it basically harder on ourselves to find an effect. Okay? But again, for our purposes, the gold standard is 0.05. Now, what does that mean exactly? Okay, if we go back to our standard normal distribution, if our p-value is 0.05, basically what that's saying is we want 5% of the population. We are looking for a score that represents 5%. So if we take that sort of and invert it, we're trying to exclude 95% of the population. Now, going back to our standard normal distribution, we talked about the empirical rule and what percentage of the population would fall at different points on this curve. Okay, and remember, the empirical rule is an approximation. So if I were to ask you, based on the empirical rule, approximately what percent of the population falls between -1 and +1 standard deviations. Hopefully you guys have committed this to memory, but maybe not, but you can go back and look. It's approximately 68%. Okay? Which means that there is another 32% out this way, correct? Okay. What we are looking for, though, is that 5% out that way, which means we're looking for the 95% in the middle. So, based on the empirical rule, approximately what standard deviation do we need to go to capture that 95%? Well, according to the empirical rule, we can go out to plus or minus, erase this, plus or minus 2 standard deviations. Okay? And at this point now, the value that falls between -2 and +2 is approximately 95% of the population. Now, when we were looking at z-scores, I did note, and hopefully you remember this, if not, it is highlighted in the z-chart table, or the z-table that Field has in his book, but there is a value at which point we know exactly 95%, not the approximate rule. And if you haven't committed this to memory yet, you need to do so. What value is that? If we were in person, I would give somebody bonus points if they could recall this, but since we're not, no bonus points. But the value is -1.96 and +1.96. So plus or minus 1.96 we know is exactly 95%. Okay? Which means, where is the other 5%? Means it's out here and out here. So if we were to go and look at the z-table, and we'll do this here in a minute, we know at 1.96, positive 1.96, that is equivalent to a p-value of 0.025. But because this is a symmetrical distribution, it's a mirror image distribution, whatever you have on one side, you also have on the other. So at a -1.96 and further this way is also going to be equal to a p-value of 0.025. So a z-score of plus or minus 1.96 equals a p-value of 0.05. 0.025 plus 0.025 is 0.05. So this plus or minus 1.96 becomes the gold standard for social scientists, I should say, not just psychologists, but for social scientists looking for a critical p-value equal to 0.05. So just to reiterate here, at the risk of being overly repetitive, if you are talking about a p-value of 0.05, we know that we're talking about the 2.5% this way and the 2.5% this way on a two-tailed test, which, by the way, you always want to run. There are occasions where some people don't, but for our purposes, we will always do the two-tailed. We're looking for 2.5% on either side. Okay, does that make sense? If not, maybe listen to this again and walk through it, or go back to the Z set of instructions and walk through that process again. But again, this is what we mean by critical p-value. All right, the fourth step then, and actually I guess I forgot to mention this, we'll basically look at this from a table. But the one thing I will say is once we get beyond z-scores, I'm not going to have you looking at tables trying to figure this out. For the most part, we have statistical software that'll do this, and it's SPSS. It'll print it out for us, so we're not hand calculating these much beyond what we're going to do at this point. So you can kind of relax knowing that we're going to let SPSS do a lot of this calculation for us. All right, the fourth step is that we want to actually conduct the analysis then to obtain the observed test value. Okay, so now we've set what our parameters are. This is the question. Part of the question we're asking is the values that fall here or the values that fall here. We're now going to run our analysis, and we're going to see whether or not it falls in this region or not. So we could imagine, let's say we're looking at a program to improve ACT scores, and let's say we finish our program and our ACT score gets some value, and we convert it to a z-score, and that z-score turns out to be 2.05. Where would we place that 2.05? Well, if 1 is here and 1.96 is here, 2.05 is somewhere out here. Is it in this critical region, this shaded area? In this case, the 2.05 would be in this critical region, and so at that point, we would say that it is statistically significant. Okay, so that's sort of what we're looking at. By the way, to further confound or confuse you, this is also called the rejection region. So you may hear it multiple ways. It's the critical region, it's the rejection region. Either way, you will hear this a lot, but it's basically the idea. This is the set of scores we're looking for and the probability related to this. If we find a score in this region, we're basically saying, hey, it's not likely to happen very often, so it is statistically significant. Okay, after step 4, then, we compare the observed p-value to the critical p-value and draw a conclusion, which is basically what I just did with the 2.05 p-value. It is in here. We would say there's some effect going on. Okay. The sixth step then is that we want to compute and interpret effect size. All right, it's not enough for us to know, is it in this region? I want to know how big of an effect are we talking. All right, am I talking a 1-point improvement on my ACT or a 20-point improvement on my ACT? It's going to make a huge difference in what I think about the research and specifically that program. And then step 7, we're going to construct and interpret the appropriate confidence intervals. Again, we want a range of scores that we're fairly confident reflect the actual population value. Okay, so those are the 7 steps. Now let's look at an example in the next presentation.